Good morning to Doctor and fellow friends. My name is Yong He Ming.
My name is Li Wenyi.
My name is Tan Zhongjie.
My name is Liu Henglong.
We are from Group 4 ECB, and today we are gonna present our assignment to Doctor and fellow friends.
So we will now talk about the circuit. First of all, the AC source that we choose is 10 volt amplitude and the frequency is 50 Hz. So the equation for the source is 10 sine 2 pi 50 t. And this is our circuit. It contains 4 resistor, 2 inductor and 1 capacitor. So it is connected to 330 ohm resistor and then connected to 560 millihenry and 220 ohms resistor, and then parallel to 220 ohm and one capacitor 0.47 microfarad and one inductor which is 220 millihenry, and finally parallel to one resistor which is 430 ohms. And then we connected the component onto the report according to the arrangement of the simulation. The yellow wire is the AC source. Then it is connected to 330 ohm resistor and then connected to a 560 millihenry inductor and one resistor 220 ohm. And then it also parallel to a resistor 220 ohm and then connected to the capacitor 0.47 microfarad and the 220 millihenry inductor, and finally connected to parallel to a resistor 430 ohms, and the resistor is connecting a wire to the ground to the another part of the source.
Okay, now this is the circuit layout that we have drawn using the simulation of Proteus, and we have simulated it by connecting all those branch including source and every kind of component connected using the AC voltmeter, and we can see that the first one is 7.07 volt, and this is actually the VRMS of the source, which is 10 sine 2 pi 50 t. But what we find using hardware setup connecting to the digital multimeter is 4.40 volt. Next, we found that the voltage across the first R1 branch is 4.45 using simulation, but 2.12 in hardware setup. Well, the next branch, which is across L1 and R2, the voltage is 2.80 volt for the simulation, but 3.24 volt for hardware setup. Next is the voltage across R3, where we find 0.95 volt for simulation, but 2.64 volt for the hardware. Then the voltage across C1 and L2 is 1.85 for simulation and 1.50 for the hardware setup. And lastly, the voltage across R4 is actually the same as the voltage across C1 and L2, which is 1.85, and hardware setup is also the same, is 1.50.
In this assignment, we are also required to measure the current for each branch in the circuit that we used before. As we can see, we find 5 current in this circuit, which is the current passed through R1, the current passed through L1 and R2, the current passed through R3, the current passed through C1 and L2, and the last current passed through R4. In simulation, we get the current passed through the branch R1 is 13.5 amps, but in hardware setup, we get 6.33 amps. Next, the current passed through L1 and R2 branch in simulation is 9.96, but in hardware setup, we get 2.98. And the current passed through the branch consisting R3 is 4.31 amps. In the hardware setup, we only get 3.55. And the next current is the current passed through the branch C1 and L2. In simulation, we get 0.28 amps, but in hardware setup, we only get 0.22. And last, the current passed through the branch R4 in simulation, we get 4.30 amps, but in hardware setup, we get 3.55 amps.
So now I'm gonna present on the part of the I will explain on the reason why the voltage meter reading, as you can see from here, from simulation and the digital multimeter is different. So first, as you can see from the table, some of the voltage value has different so for this one, for example, for this one, got 2 MV to 3 MV difference. For the next one, for the current one, as you can see also, there's about like 5 milliampere to 7 milliampere difference. And then, so let's get back to the next last slide. Okay, so I will explain from here. So instead of seeing this kind of situation, our group have do some like checking on this part. Well, before the hardware setup, we have just connect the signal generator to the digital multimeter, just in order to check is there any problem with the signal that generated by the signal generator. But we have got the evidence that we have taken a picture. Maybe we will put at the appendix, and then as from that picture, the reading we get is 6.88 voltage. So for the 6.88 voltage is almost like, okay, this one is almost similar with this one, the 7.07 voltage from the simulation. And then next, we have also proved that the voltage and the current values that we get obtained from the digital multimeters are acceptable. This is because of just very simple. The reading that we get is for the voltage and the current, some of the voltage and the current, like for the source one, which is obey to the Ohm's law. And then for the first branch is obey to the Ohm's law. So this can say that the reading that we get is acceptable. So next, some of the value that is different much from simulated reading is maybe for the reason that we think that we get is probably is due to the inductor and capacitors. For inductors are components which are able to store energy in the form of magnetic field. So so it's safe into the SF in the magnetic field. So nature of both components will easily contribute to the value difference among both ways. So among the simulation and the hardware. So okay, next part. Okay, so after the previous reason, we have also done some research on internet, and we found out that there is this problem maybe related to the breadboard we use. This is because the resistance does exist in the breadboard, hence it may reduce the voltage that's applied to the circuit we have set up. So that's all from me, and I think maybe this one is I'm the person who stopped this presentation. So thanks for watching, and thank you.